For each of the kinds of variables we have, we've identified them in two different ways. I'm going to be switching from this levels of measurement, nominal, ordinal, interval, and ratio, to the mapped on version that you can see over here of dichotomous, count, and continuous. If we want to describe binary variables or dichotomous variables, those mean the same thing, then we need to use a set of simple tools to do so. If I want to describe a sample in terms of gender, I can say what percentage of my sample is male or female. So percent is a very common way in which we will describe dichotomous variables. How many people within my sample fall within category A, fall within category B, fall within category C. And you can use that for nominal variables, but you can also use that for ordinal variables. So if I ask a question, how good is your health? And some people can, some people respond good, some people respond fair, some people respond poor. I can say 20% of my sample described their health as poor, another 30% described it as fair, and 50% described it as good. So I'm using these percentages to describe who falls in what ordinal category within that variable. So percentages or frequencies, how many people endorse it, are generally the ways in which I describe my dichotomous or my ordinal variables in a descriptive kind of way. But if I have a count variable or a continuous variable, I generally use a set of different tools. So one common tool is a histogram, and you can see an example of a histogram here. Histograms are really great ways to see the frequency with which certain categories are endorsed over a population. So for example, if I'm thinking about age, you can see this example here is a histogram of a population with respect to their age. So I know various things. I know how many people are older, how many people are younger, and where the majority of people are. So on the y-axis, which is the axis over there, this is the x-axis, that's the y-axis. The y-axis tells me the frequency with which individuals are X year old. And the x-axis tells me the age. So the y-axis is frequency, the x-axis is age. And this is a common way of organizing and categorizing individuals. And it shows me the distribution of age within this particular sample. The histogram is a wonderful picture and a good starting place for understanding any variable, but often we want to quantify things in a more specific form of way. And for continuous variables, the way we quantify them is through the use of means and standard deviations. These are called measures of central tendency and measures of dispersion. So where is the middle of my histogram? And how spread out is my histogram? So mean or median or mode would be measures of central tendency, whereas standard deviation and variation are measures of dispersion, how spread out a population is. And those tell me slightly different things about something. So let's first start with measures of central tendency. The first measure of central tendency is the mean, which is just simply an average. So you take all of the scores in this class, you add them up, you divide them by the total points possible, and that's your average score in this class. We're all familiar with calculating averages. And it represents the point in the distribution where if you add up all the ones above and you add up all the ones below, you will have a 0. The second type of measure of central tendency is the median. And the median is the midpoint in a range of responses. So if I have a set of numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5 is the median point because it is smack dab in the middle. There are 4 numbers before 5 and 4 numbers after 5. And so 5 represents the midpoint of the distribution. There are different points in time in which we would want to use a mean or a median. And there are specific circumstances. So the general rule is, if you have a bunch of outliers, you want to use the median because the median ignores the outliers. It just ranks everything and finds the middle point. The mean absorbs the outliers, and sometimes that can skew our results. A very typical reason why we would use a median rather than a mean is in describing income. So let's say we have a town in Maine that has 100 people in it. Most of the people in that town are involved in the tourist industry, and most of this, the vast majority of them, everybody but one person in this town makes between $20,000 and $60,000. But that one person happens to be Stephen King, and he makes millions and millions and millions of dollars. If I average up everyone in that town, the mean number, the mean income for that town might be $200,000, when in fact no one in that town makes $200,000. 99 people in that town make between $20,000 and $60,000, and then one person makes $10 million. So if we add up all of the incomes and divide by 100, we get a number, $200,000-$300,000, which describes actually nobody in the entire sample. But if we take the median and we line up all the people and all their incomes, Stephen King out here at 2 million is no different than the person right next to him at 60,000. He's just another number at the end. And the midpoint of that distribution, let's just say it's $40,000. So you have 20, 30, 40, 50, 60, Stephen King over here. So if we say 40,000 is the median versus 200 or 300,000 as the mean, which number best represents the typical person's income in that town? Well, of course, it's the $40,000. So in cases where you have a skewed distribution or very severe outliers, the mean can often misrepresent what is actually going on. And in those cases, we use a median. In most other circumstances, in most circumstances in statistics though, we rely on the mean. It's the most common form of measure of central tendency. So what's the mean age of a population? There's not a whole lot, generally we don't have a huge outlier. So if you're working in a child welfare agency, you're going to have a range of kids from just born to 18, maybe depending on the program, 21 years old. But that's a relatively restricted range, and the mean is going to be pretty informative. A third form of measure of central tendency, and one that we don't actually use that often, but is sort of useful in some circumstances, is the mode. The mode is the most commonly endorsed measure. So the mean is the average, the median is the midpoint, and the mode is the most common. And those are the three primary measures of central tendency. The second thing that we talked about that we said was a useful form of understanding continuous measurement are measures of dispersion. How spread out is our distribution? And the typical way that we measure that is with the standard deviation. Simply stated, the standard deviation is the average distance from the mean. So the mean represents the middle of the distribution, and the standard deviation represents how spread out that distribution is. So a smaller standard deviation means a tighter distribution. A larger standard deviation means a wider distribution.